Up till now, for the most part, we've been plugging numbers into functions and getting out numbers. But there's nothing that says that you can't take a function and set it into another function. Okay, and that's what we're going to talk about today. These are called compositions of functions. When you input a function into another function. Now, this is notation that you should feel familiar with because it just looks like I have plugged in g of x inside of f. So this is f of g of x. But you will also see this notation used from time to time. F with a little open circle next to g. So this looks like f of g. That makes sense, I suppose. But it means that g is being input into f. So we'll see both of those notations used. Let's jump right into some examples. If f is the square root of x and g is the square root of 2 minus x, then we can come up with several compositions right off the bat. So f of g of x, what would that mean? That would be f of the square root of 2 minus x. That's what g of x is. And so what does that mean we do? It means we take our function f, which is the square root of my input, and we do the square root of 2 minus x as the input. So you have the square root of 2 minus x, which could be simplified, if you like, to 2 minus x to the 1/4 power or the 4th root. G of x would mean g of f of x would be g of the square root of x, which means let's take our function g, and everywhere there's an x, we replace it with a square root of x. So here you have the square root of 2 minus the square root of x. You can even compose functions with themselves. So in this case, we would do f of the square root of x, which means take my function f, and everywhere there's an x, replace it with a square root of x. Again, you could simplify this, if you like, to be either x to the 1/4 or the 4th root of x. G of g would be g of the square root of 2 minus x, which means take your function g, and everywhere you see an x, you replace it with a square root of 2 minus x. Interesting compositions. Those aren't so bad, but what you really have to be focused on here is what is the domain of the final product here. Okay, so when you compose two functions, you're going to get this new function. And what's its domain? Okay, well here's the deal. Number one, you look for the normal restrictions on your final equation. So far those restrictions are dividing by 0 or having the square root of, an even root of a negative number. Okay, so you look at your final equation, you'll say, okay, I can't have this number go in, or I can't have this number go in. Nothing different there. But here's the thing, you have to also consider the restrictions on the original function that was being composed here. Okay, because if a number could not have gone into g, it would never have come out to go into f, so it can't be in the domain of f of g. Okay, so we'll consider the domain of, I'll write it as the inner function. Okay, the domain of the quote-unquote inner function. And you may forget to do that because sometimes you do simplifying and it doesn't make it obvious that you have to go back and consider the original domain of the inner function. In this case, it's g. All right, let's do some examples and you'll see how it works. So here's f, the square root of x. Here's g, 1 over x squared. Let's find the composition g of f and then find its domain. So g of f would mean g of the square root of x, which would be 1 over the square root of x quantity squared. Okay? Now, if I choose to simplify that, which most of the time we do, we'll get 1 over x. Okay? So I'd say, all right, g of f, I'll write it like this time, g of f is 1 over x. Now, if I just look at this, I would say, well, okay, I'm not allowed to divide by 0, so x can't be 0. But it turns out that that's not enough of a restriction to make on this composition. All right, we got to go back to the original inner function, which is f, and look at f's domain. And look at this, it's a square root of x. So that tells us that if I was just looking at f, then x had to be bigger than or equal to 0. So I got to combine these two domains so that they work for the entire function. So this says x can't be 0. This says x has to be bigger than or equal to 0. So that means we're going to take the 0 part off of that. And so the domain for g of f in the end is going to be all real numbers that are bigger than 0. So I'll write that as 0 to infinity, not including 0. Okay? So here's a picture that maybe will convince you that this is correct. All right? The graph is of 1 over x, but with this domain, 0 to infinity, because 1 over x would normally have a bigger domain. But because it was a composition, we had to restrict part of that domain. Okay, let's see this one. We have f of x is the square root of x once again. G of x is now x minus 2 quantity squared. Find the composition f of g and then its domain. So f of g would be f of x minus 2 quantity squared in there. Okay, which would be take your function f and everywhere you see an x, replace it with a x minus 2 quantity squared. Okay, most of the time we like to simplify if we can. So f of g of x would be the square root, the positive square root of something squared. Okay, that's going to be the absolute value of x minus 2. Sorry, that's how it is. We've got to go with it. Now, this has no restrictions on it if I just look at this. So I would think, okay, the domain is all real numbers, no big deal. But I got to go back and double check that the original inner function, which was g, had no problems either. And I go back to g, and g has no problems because I can plug anything I want for x here. So it has domain all real numbers, and so this domain is okay. We can plug any number we want into the composition, and something will come out. All right, here's a picture. Looks like an absolute value function, doesn't it? That's been shifted 2 units to the right. That would be the absolute value of x minus 2. And it looks clear that this goes on forever in both directions. I have good domain. Okay, one more example. This one may throw you for a little bit of a loop. I like it. So we have the function g of x is the square root of 2 minus x squared. We're asked to find the domain of g of g. So let's find g of g. Okay, g of the square root of 2 minus x squared would be what? Well, g says take the square root of 2 minus my input squared. Okay, so my input squared. My input's now going to be g, which is the square root of 2 minus x squared. Now, what happens next? Well, a square on the outside does cancel a square root. So on the inside, we simplify to 2 minus the quantity 2 minus x squared. Okay, what happens now? 2 minus 2 is 0, and negative x squared is just a x squared on the inside. And here's our favorite problem. The square root of x squared is not just x, it's the absolute value of x. Okay, so that's what g of g comes out to be once it's simplified. Now, here's the fun part. What's the domain of g of g? Well, if I just look at the answer, I would say that the domain is all real numbers. Okay, that's what I would assume if I just looked at that. But I have to be sure and go check the original inner function. The original inner function was g. Now look at g. G has some problems, right? Because it's a square root, and in square roots we have to have the inside of the square root must be greater than or equal to 0. So I need a sign chart because this is a nonlinear inequality. What makes 2 minus x squared 0 are the positive and negative square roots of 2. And if I do sign tests, I'm going to get negative, positive, and negative. So the domain of this g, original g, is going to be negative square root of 2 to square root of 2. I have to combine these domains so that they make sense for the whole function. This says use any number you want. This says only use these numbers. So I have to reject this domain. We have to take the smaller of the two, and we're going to use this as the domain. So check this out. G of g is the square root of x, but only on this interval. So what you're going to see here, and this is what you would get if you graphed it on GeoGebra or your calculator, is you'd see only a portion of the square root of x function. Okay, it starts at negative square root of 2 and ends at positive square root of 2.